Assalamu alaikum. I am Muhammad Mir Hassan Sam. My ID is 22147618. I am from Department of Civil Engineering, Dhaka International University. Welcome to my presentation. My presentation topic is about falling head permeability test. So I am going to about present this to my teacher Muhammad Mamunul Haq, Assistant Professor, Department of Civil Engineering. So falling head permeability test, reason behind this test. First point is soil properties. Helps engineers understand the intrinsic properties of the soil or rock formation, such as porosity and hydraulic conductivity. Water flow characteristics. By conducting a falling head permeability test, engineers can assess how water flows through different soil types. Groundwater studies. Understanding the permeability of soil layers is critical for groundwater studies. Geotechnical engineering. The permeability test results are used in geotechnical design to ensure the stability and safetiness to structures built or into the ground. Environmental impact assessment. Understanding soil permeability is crucial for assessing the potential migration of contaminants through the soil and grounds. Now I am discuss about the objectives of this experiment. So first object is to determine permeability of soils intermediate and low permeability less than 10 to 4 meter per second silts and clay. To describe the general accepted practice to determine the coefficient of permeability of silts and clay. To identify the relationship between permeability and pore size of the fine-grained soils. To measure the coefficient of permeability of silts and clays. To determine the coefficient of permeability of a fine-grained soil such as fine sand, silt or clay. The test may also be used for coarse-grained noila. Okay, now our next comes apparatus. So these are the apparatus. So apparatus to prepare and carry out falling and head permeability tests are the number one is parameters device as shown in figure, this parameter, and the second one is stand pipe with ring stand and clamp. This is the ring stand and clamp. Distilled water thermometer, graduated cylinder. These are the graduated cylinder, and ruler scale. This is the ruler scale, and last of all is a vacuum. So I'm going to next comes a procedure of this test. The falling head permeability test is used to determine the permeability of a soil sample. Here is a short overview of this procedure. First one comes setup. Place the soil sample in a parameter with a known cross-section area. Make sure the parameter is completely filled with water and there are no air bubbles. Initial water level. Start by adjusting the water level in the standpipe as to a known height above the soil sample. This is the initial water level. And the third is start the test. Open the valve at the base of the parameter to allow water to flow through the soil sample. Start the timer. Record data. Next one comes to record data. Measure the time it takes for the water level in the standpipe to drop a specific distance. Note the initial and final water levels. And the fifth one is calculation. Use Darcy's law to calculate the permeability of the soil sample based on the head loss, time, cross-sectional area, and other relevant parameters. And last of all is repeat. Repeat the test with different water level and record data for each trial to ensure accuracy. Remember to follow the standard procedures and safety guidelines when conducting the falling head permeability test. Now Next comes is test procedure. So test procedure, first of all, measure the inside diameter and height of the parameter cells to determine the standpipe area by measuring the volume of water contained in a standpipe section of a given height. Put the soil sample on the filter pipe paper in the parameter for coarse soil by placing a known weight of the sample to determine its unit weight, and for the fine soil by compaction inside the parameter cell compaction mold or using undistribute sample. And third one is put the filter paper on the top of the soil sample and assembly the top part of the parameters device. Fourth is saturation. Saturated the specimen by immersing in water for 15 minutes. It is important that the specimen is full saturated, otherwise the falling head test will give erroneous results. This then apply a vacuum to remove an entrapped air in the specimen, prevent to re-enter air to the specimen before testing by closing the clamp. Now 5 is locate H1 and H2 on the standpipe, then fill it with distilled water. Commence the 6 one is commence the flow of water and simultaneously start the timing the test. Allow water to flow through the sample until the standpipe is almost empty or to a convenient mark. Simultaneously stop the flow and timing. Obtain the head H2. Take the temperature of the test. Refill the standpipe and repeat the test two additional times. Use the same H1 H2 values and obtain the corresponding elapsed times. Take the temperature for each run. So by using this procedure test, we will find out the next one, and that will be our falling head permeability test. Okay, then our next one is comes theory background. In the falling head test, here it is said that in the falling head test, a relatively short sample is connected to a standpipe which provides both the head or water and the means of measuring the quantity of water flowing through the sample. Several standpipe of different diameters are normally available, from which can be selected the diameter most suitable for the type of material being tested. In permeability tests on clays, much higher hydraulic. Okay, and in theory we will use this formula, uh, formula formula permeability K is equal to L by A into T2 minus T1 log H1 by H2. Okay, then this equation also comes. So here's written that the time difference at T2 minus T1 can be expressed as the elapsed time. The height H1 H2 and the length L are expressed in millimeters, and the area A and in a square millimeters. Okay, now here is the calculation. So we will use this calculation for the experiment. So first experiment is calculation is KTAL by 80 into ln H1 by H2 centimeter per second. Okay, so by this calculation we will find out the falling head permeability test. So this is the sample of falling head permeability test. Sample diameter is 99.21, sample length, sample area 7730.38, sample volume, and this is the calculation of a sample of falling head permeability test. So after that we will calculate. Here is the calculation. By calculating, we find the permeability K1 is equal to 8.51 into 10 to the minus 7 meter per second. K2 4.39 into 10 to the minus 7 meter per second, and K3 3.39 10 to the minus 7, K4 2.7 into 10 to the minus 7 meter per second respectively. After that we will talk about the discussion. So the test of falling head permeability test is carried out to determine the permeability of soil of intermediate and low permeability than is less than 10 to the power 4 meter per second. The coefficient of permeability is defined as the flow rate under laminar flow conditions through a unit cross-sectional area of porous medium under unit hydraulic gradient. The coefficient of permeability for our soil sample is KT is equal to 8.51 into 10 to the minus 7 meter per second. These are the samples we are talking about, and the K2 and K3 and K4 respectively. So the average for the coefficient of permeability is 4.7475 into 10 to the minus 7 meter per second based on figure 3. Which figure? This figure. After that, the sample of soil is classified as a silt or clay, silt clay. From here we know that the silt clay comprises mainly of intermediate size particles are fertile, fairly well drained and hold more moisture than sandy soils but are easily compacted. Silt as a soil separated constants of mineral soil particles then 0.002 to 0.05 millimeters in diameter. Silt has a relatively limited surface, so to say. So that's all. Thanks for watching my presentation and giving me time. So that's all about falling head permeability test. Thank you.